Hello, everyone. I hope you're having a great day. I saw amazing persons outside. Guess we get a chance to talk later. Hello, like I said, they introduced me. I am Anita Ihuman. And today I'd like to ask a quick question. As developers, what is worse than having to deal with bugs in our code base whenever you're done and you feel like you're actually done, but then it pops up in production and you have to deal with it? I know we can all relate to that. If you can just do like this. And then you have to deal with the bugs, but then it becomes more strenuous to get rid of them because the process is exhausting, or you have to deal with the redeployments, the rebuilding, and all of that circle. It takes a long time. Sometimes it can be frustrating, especially for the developers. And so today, I would like to talk about how we can get rid of these pain points for our development environments and how Remocal development can save the day. During this section, I would look at the conventional development environments that we're familiar with. And then, in as much as they work very well, I'll also try to point out some of the challenges with some of them and why there is need for a remote code development when there's like the local and then there's the remote existing, why we need a remote code development on its own. So we're going to look at how Miradi, an open source project that my company at Metal Bear is working with. By the way, if I forgot to mention, this is my company's name, Metal Bear. We build amazing projects for backend developers, and one of that is Miradi, which basically is a development tool to make the Kubernetes developers' life easier and seamless. Now, to start with, the inner loop and the outer loop. We all familiar with, as developers, we want to be able to write code. Once the code is working, make a push to GitHub, and then you're done with and you move on with your life. It would be amazing if life was that simple, right? But then the challenge here is, after you're done with that, you have to also take into consideration what happens after the code is pushed. Then we're going to look at how it is integrating with the back end, the code reviews, how it builds the compliance, security, and so many other things. Because you don't have to end at the first step. You have to see to the end. And then when it's finally deployed, what happens to the code base you just made in production? Did it break anything? Does it work perfectly? If you're unfortunate and it breaks something, then you have to start all over again and then go over it. It won't be a problem if we just had a single pager that we're doing all of this with. But our applications today are really complex, really large, and so like there's so much going on. You have to repeat this circle over and over and over again. And for cloud native tools, right, one amazing thing is there's always a solution for any problem that comes up. But some of the solutions that come up bring like more problems with them. So we also have to figure out how to solve that. Well, microservices came in, and a lot of persons probably know about microservices. The chunks of code that are able to communicate with themselves but also function independently. Yes, they came up, and most applications today have hundreds to thousands of microservices. And so many developers are working on these services. And now look at the first instance I gave of like writing your code and then making sure that it goes through an entire pipeline before it gets to the end, right? With microservices, it becomes even a lot more tedious because now you have to make sure every single developer that is writing their code base does it right, the versioning and everything works fine. By the time it gets to the production, nothing goes wrong in the process. And the challenge with these, or the challenge that came along with these microservice applications is first, developers now had to deal with lengthy rebuild and redeployment processes. Do we all know this Nigerian advertisement that came out that time where they say, you don't clear, you don't show, oti clear, oti clear. So imagine you're trying to like set out a satellite dish for your house, but then you don't have anybody in the house telling you, oh, it's working, move it to the right or move it to the left. So you have to climb the ladder, make sure that it's positioned right, come down from the ladder, check your TV. Is it working? If it's not working, you go outside again, climb up and do all of that. So that is basically what the development process with most of our applications look like. And this is really, really excruciating because imagine you're someone who is setting up these dishes for like 20 houses or 30 houses, and let's call that a microservices. By the time you're done, not only are your legs going to pain you from climbing the ladder up and down, but then even the shows you want to watch, you get exhausted along the way. And then you also have to deal with the suboptimal testing conditions, right? Because sometimes you might be able to develop like mock samples where you can test your code base and make sure that it's working. But the problem with this mock is it doesn't also come with all of the resources that the application would use in production. And so no matter how much you try to replicate it, it still doesn't give you like 100% assurance, and issues could come up in the process. And then developers now increasingly become dependent on like DevOps, because now teams are working on a shared staging environment where whenever a change is made, everyone stays in line to make sure that it's tested in the staging. And you can't even push your code without testing because you don't want to break anything. So like there's a lot of workload for the DevOps, and then there's a lot of queue in the process. And it's just a whole lot of headache for the developers. And like I said, there's so many solutions that have been brought up to solve some of these, and one of which is the local development environment. So someone said, instead of having to go through this long process, let's just have all of the resources our applications need, right, on the computer. The databases, the file systems, and all of that. Let's have it on the computer so we can easily get it done with. This is an amazing solution, you think, right? Because it gets rid of the long process. The developers are familiar with their environment, so you can easily just get things done. But it's only good for a while, because as your application grows bigger and the microservices get larger, this will not be conducive for you to actually manage. And there's so many solutions that actually cater to this. We have micro K8, mini cubes, and the likes. But like I said, it doesn't last long. The benefits of it don't last long, especially as you're scaling the application and things are getting more complicated. Now you have to deal with like the difficulties of or impossibilities of the application growing with this particular method. Because, like I said, if you have hundreds to thousands of microservices, this might not be achievable on your computer because it could crash. Do you get? So over time, it becomes not conducive. Then the developers have to now manage and maintain the environment. The mock environments that are set up, developers have to make sure that it is constantly updated to stick in line with the versioning, and so many other things that have to put into consideration before the application is eventually merged. And this maintenance also becomes hectic. And then it can sometimes be incompatible with like specific processor architecture, because while you're working on your system and you think it looks very good, Mr. B is working on a different processor architecture, and the libraries might not work as well as they work on yours on his laptop. And in that situation, what are you going to do about it? So you see now that it may be cheap, it may be smooth and really, really easy to get started with, but it has its downsides. And then there is also like the remote development environment where everything like the database and all of the cloud resources are actually available in a remote cluster somewhere. And this is really a good way to get rid of some of the issues we talked about with local development, right? But like every solution, it also still has its downsides. And there are amazing solutions for this. You have Amazon EKS, Digital Ocean, Civil, and so many other platforms that are able to solve some of this, right? Like I said, all of the shared resources are actually available in the cloud server. So you don't have to deal with it on your system and like any other complexities. It's sweet for a while, because then over time you realize that there's actually the problem of long feedback loops that actually slow engineering effort, because this now has to go through a process of dockerization and then pushing to the registry and then going through all of that before the code bases are eventually accepted to production. Then you also have to deal with like the frustrating debugging experience. Unlike the local where you're familiar with all of the tools or it's actually on your system, you have to try to understand some of these cloud environments, how they work, and then get started with the whole process. And there's like a high cloud cost associated with this, because now you're thinking of getting an environment per developer so that they can get their works done. And this, the cloud environment has its specs, right? Because you say, if I make a push, then CI/CD can complete the rest. But then while that is put in consideration, imagine you have hundreds to thousands of developers and you have to think of the cloud cost per developer. Over time, this becomes a whole lot of money that is put into it. And so developers need an environment that is not stressful to actually get started with, gives them the benefit of the cloud, something they can relate to without having the fear of if the code base is pushed to staging or if it gets to the final destination, I will not have to repeat this process again 100 times or 1,000 times, depending on like the complexity of the project. And that is where the Remocal, remote to local development comes in as a golden path. So what the remote to local development is basically trying to do is acting as a bridge, right, between your cloud and then your local development environment. So you can have access to what's the cloud, the databases, the file systems, and network, and all of that, but you're writing your code and everything on your system. And so you don't have to deal with the length of learning some of these tools to get started and all of that. In simple explanation, this is basically what it gives you. You have a combination of the local as well as the remote environment. And a good instance I would like to use is in that advertisement where they were trying to test the network, the satellite dish, whether it is clear or not. Now you have somebody as a middleman in the sitting room that is telling you, no, it's not clear, move to the right, push it to the left. It's not clear, bend it up a bit, come down, and then eventually you realize that, oh, my DSTV is working, now you can watch the movie you want. So like that is basically a picture, as explanation of what remote development is all about. And the advantages that this comes with is you get to enjoy the consistency between your local and your remote environment. Because now you're not, you don't have everything on your system, but then you still get access to it in such a way that you can test what the application would look like in production without breaking anything. It's easy to use because you're still on your system making every changes or debugging, and you're familiar with the softwares that you're using, so you don't have to like go through the long, lengthy learning curve. It gives you like a fast feedback loop, because then it's more like a shift left on testing. So instead of waiting until you get to the final stage of like your CI/CD before it is tested, you can actually do that as the initial phase at every change, see what it looks like before moving forward. So like you cut off the long hours of waiting to actually see what your changes look like. And then you save a lot of cost in the process, because you're not paying an outrageous amount for like a cloud environment for your developers. You can actually moderately measure and weigh all of that in terms of like the maintenance cost and all of that. Then you also get the best of both worlds. the benefits that the local environment comes with, as well as the benefits that the remote environment gives you. So you're enjoying all of that without the drama. And one tool that I would like us to look at, that there's so many solutions that actually do this. I think telepresence is one, but Meridi is another that I would like us to major in. Meridi is a project from Metal Bear, our flagship project. And what Meridi does is it basically makes the Kubernetes developers' life a lot easier. Like I said, the idea is you don't have to go through all of the drama and all of the chaos. You can actually cut your long time development process by a few minutes with Meridi. It comes with a CLI and IDE plugins that you're all familiar with. You can use it in your VS Code and IntelliJ plugin. It allows you to run your local process in the context of the cloud environment. So like as you're running your processes, you can actually see what it would look like against the cloud environment from the start of your process. You can actually work locally, but also enjoy the remote shared environments that your team is using. Meridi gives you the convenience of the local development environment that every single person would want, but sadly, it becomes chaotic on its own. And then it also comes with all of this, it gives you like high development velocity, saves you a lot of time, faster time to market, because you don't get to the last stage before you figure out your problems, only to come back. You can figure it out from the initial stage, and there's lower cloud cost. And there's a lot of explanation there, but this is basically what I'm trying to say. Meridi works in this way, right? It comes in two components. There is the Meridi layer, and then the Meridi agent. When you enable Meridi on your system, your VS Code, or any IDE you're using at all, what it does is it creates a pod called the Meridi agent that is being inserted into your the target pod that you're particularly specifying. And this Meridi agent runs on the same network processes as your pod, your specified pod. And so it has access to the file system, has access to the data, the DNS, and any environmental variables that your application will need in production. And then the Meridi layer, which actually exists on your computer, what it does is it integrates itself with like your local system, and then gets to like reroute and also reroute traffic that is coming in from the remote environment to your local environment. And so what you're getting at the end is whenever you make a call, or like there's a call made to your application when you're running your changes, Meridi kind of mirrors the states of the cloud, gives you the feedback like it would if you were actually running the application remotely. And this comes with mirroring or stealing of traffic, whichever one you decide. I'm going to differentiate both soon. Mirroring or stealing of traffic, and when you steal traffic, it gives you like a reroute and of what the environmental variables look like, what the DNS could look like, the out and incoming traffic. You're able to specify all of this as well as the file system for that particular pod that you're working with. And basically, that is what Meridi does. And at the end of the day, when you're writing your code, it feels like you're in a cloud, but the truth is you're actually on your system, and everything is being done locally on your system. And I think this is basically what I'm trying to say. It has access to whenever a call is made to the application that you're trying to test, the Meridi agent is going to reroute and like forward that traffic to your local environment, and you're able to see what your application would react to in terms of that particular feature you just implemented, or in terms of whatever new ad that you actually just made to the code base. It gives you like a real-time interpretation of what it would look like if it was in production, saving you a lot of time and all of that. And the best of it is not invasive to your system, right? So you don't have to struggle with, oh, Meridi is going to overtake or rewrite anything in my cluster. It just exists there for the moment of your debugging process. Once you're done with the entire process, the Mirror agent, which is in your cluster, terminates itself, and you can go back to your day without struggling. All of this is done in a matter of a minute to two, and which shows you the speed at which all your development process can be hastened if you actually use the right Remocal development tool. And this is what the development feedback loop when you're using Mirror looks like, because you're able to do like shift left on your staging and shift left on testing. You get to write your code and then test immediately. And you don't have to say, let me wait till it's complete, CI/CD process is completed before I will proceed with my application, right? You see the changes immediately. It looks close to perfect because it's giving you like a real-time interpretation of what the resources would look like in production. So you can just push and not have to deal with any issues. It gives like 0 to no production errors at the end of the day. And so you're getting like immediate tests in cloud condition. You're spending less times configuring and updating your mocks and simulations. And then there's low chance of failure whenever you get to like the production at the end of the day. And I know I've been doing a lot of talking, but I'd like to give us like a short run through of what this would look like if you were actually using Mirror for like a very complex microservice. So I have a small project here, a Python weather site that I put together. And basically, it makes a call to an API, and then it gives like interpretation of what the weather in different cities are. And so, this is what my application looks like. I don't know if you can all see it. Is there a way I can zoom on the screen? However, what I'm trying to do is, this application is already running, and this is what it looks like. If you type allweather.world, this is what you're going to get, today's weather. And let's check the weather in Lagos. For instance, it's going to give us what the weather looks like in Lagos, the conditions and all of that. And assuming I'm working on a very big and complex microservice application, I want to make this a particular change to a section of my microservice application. Assuming this is my microservice, I want to change the color of the display, the output, and I don't like that it's light blue. I like to give it a different color altogether. So let's go to the code base right here and look at the. So let's try something bright and red. Now I'm using this simple instance, but like if you're using even a more complex application, regardless of whether it is using a service mesh or whatnot, Mirror actually works on any application that uses any environment at all. So you can also try that. And I also want to change this today's application header to. So I'll just change that to Anita's demo project. And what happens is Mirror is already an extension on my system, but if you're trying to use Mirror, you can actually check your VS Code extension and type Mirror, MIRRORD, Mirror. And then it installs itself. Once that is put in place, you have the extension available. You can set up like configurations. I already have like a configuration file that exists here that says I want it to go to the weather app deployment. That is my target pod. I want it to steal incoming traffic and outgoing traffic, and then also the environment variables and all of that. And checking every other thing. It looks good. The changes I want to make are available here, and it has demo and then the display. And immediately you initiate the Mirror at the bottom there. Once you enable Mirror, you go to the debug icon on your VS Code and hit play, in a matter of minutes, 1 minute at most, Miradi is going to actually mirror the state of what the application would look like in production, and we'll be able to see if my changes are going live. Okay, so that is it. And just like that, Miradi is already working. And like I said, what happens when you initiate Miradi is it deploys a pod into your target pod called Miradi agent. And this agent is going to be like forwarding all of the traffic that I need into my local system. So everything actually works the way it's supposed to be in real time without having to push to production. And so to test that out, I have another page here where I'm going to still run this same domain name and reload it, and we're going to see, like I said, it's also able to mirror. We see Anita's demo project compared to what was there before, Anita demo project. And if I want to check the weather for now it's giving me the red that I indicated that I actually want it to. Now this is exactly, if I eventually am done with my changes and I make a push to GitHub and it goes through the CI/CD, right? This is what the application will look like in production. There's not going to be any break at any point and the application would work perfectly. If you would also want to check it out, just type and it's allweather.world on your phones or in your browsers. You should also be able to see this exact replica of the application available. Prior to this, if you checked, you will be able to see this. But since I'm actually debugging it now, you'll be able to see this state of the application on your phones. Can anybody give it a shot? Just type allweather.world in your browser. You should be able to see this. It didn't work. Remove the S from the www. Type in, enter ACT. Exactly. So it gives you like the real-time state of what the application will look like by the time I push my code. And just to confirm that, okay, all of the traffic is coming in from your calls, and I can see it right here, there's a lot of requests being made. And just to test that, Miradi actually gives you like an existing pod into your, if you type kubectl get pods, now there is a Miradi agent that has already been immersed into the cluster. And like I said, Miradi is non-invasive. So by the time I'm done with this whole debugging process and I end it, the agent is going to immediately terminate itself, and I can now know whether to push my code to the production and go on with what I'm doing or not. And basically, that is how the magic with Miradi works. Let me cancel this and end the process just to show you. So give it a few seconds and I'll check that again. Completed. And it is gone. So Miradi has no business whatsoever in your system. It's no longer going to disturb your application in production. It's non-invasive. You can go on and make your push to GitHub. And basically, that is how this awesome project Miradi works. And another awesome fact is Miradi is open source. So you can also make suggestions and make changes to the code base. If you are working on the project and you come across an issue, we have an amazing Discord community and very receptive, always active. And you can easily reach out if you have any issues trying to use Miradi. You can also scan this QR code to check out our GitHub repository. That is all the magic with Miradi. Thank you. Are there any questions?
Okay, so I didn't really understand what that remocal development means.
Okay. All right, let's go over that. So let me use the instance of setting up a satellite dish. Now that's the simplest I can give you. When you're setting up your satellite dish, someone has to climb to the roof to set it up. And someone has to be in the sitting room to tell the person, it is working now, right? So what basically Remocal is giving you is you're able to see what the application is or what your satellite dish will look like while you're trying to set it up upstairs. So it's like having a tablet that is mirroring the state of what the TV looks like, what the satellite dish display at each angle is. That is basically what the remote development is, right? So like it's mirroring the state, and then you're seeing it right on your tab, every single thing that the TV at every angle with the satellite dish looks like would display. So basically, that's what Remocal is all about. Thank you. All right, thank you so much. And feel free to hit me up if you have any questions.